Okay, for this video, I'm going to try something a little different. I'm going to show you the book, and then I'm actually just going to show you a quadratic formula and a parabola, a parabola, and manipulate it a little bit. So the basic concept that we started this chapter with was changing that value of a. And remember, if we change the value of a and make it greater than 1, it's a stretch. If we make a value between 0 and 1, it's a shrink. And if we make a negative, it's an X reflection. So those are all the things that A can control. Today we're going to focus on what C does. Now, obviously, once you start changing more than one thing, there's going to be more than one transformation to the parent graph. I do want to address this picture here because it's kind of misleading. So the blue function is your parent graph where A is equal to 1 and C is equal to 0. The green graph, it says when C is greater than 0, it's going to go up. Now, again, it's just taking the whole function and moving it up. Don't be misled by the picture. It's not shrinking it. It's not flattening it out in any way, shape, or form. It's simply just shifting that parabola given up. Likewise, if C is less than 0, it's simply shifting the parabola down. Now, the one thing that I do want to address is that when you shift C up or down, the domain does not change. Your transformation is up however many units C is or down however many units C is. But when you shift a function up or down, that changes the range of your function. Instead of it being greater than or equal to 0 or less than or equal to 0, your function is simply going to be greater than or equal to this value C from here on out. That value C is going to dictate where that vertex is. Okay, and then tomorrow we're going to add B into the mix, and then we're going to really fixate, instead of on specifically C, we're going to fixate on where our vertex is, and that will help us determine what our range will be for the entire chapter instead of just for these first two lessons. So now that we've kind of discussed this and you guys have had an opportunity to look it over, if you need to, pause, write any of this stuff down. But when there is no B value, your axis of symmetry is still on the y-axis. Your vertex gets changed to 0, C, whatever C is. This vertex is going to move around a little bit on us once we throw that B in the mix. So I don't want to focus too much on that. What I do want to illustrate for you, though, for the lesson that you're going to do in the Google Forms is this Desmos thing here. So here is our parent function. Again, our A value is 1, our C value is 0. It hasn't shifted up or down at all. So if I take, let's say, C and make it -7, we now have this function here that is shifted down to -7 on the y-axis. It has moved down 7 units. It's the exact same function. There's no stretch, there's no shrink. I've just moved down the same function that you see. The domain is all reals. The range is y is greater than or equal to -7, because that's where your function starts. The transformations, there's no stretch, there's no shrink, there's no reflection. There is a translation down 7 units. So that's what we would put for our transformations, down 7 units. Let's consider another example. Let's consider, instead of x squared minus 7, let's consider x squared plus 2. What do you think it's going to do? Obviously, it's going to move your function up 2 units. So again, let's go through that list of things that we talked about in the first lesson. The domain, all reals. Range, instead of y is greater than or equal to 0, it's going to be y is greater than or equal to 2. And then for transformations, we're just going to say up 2. That's it. That's the only transformation that happened. So now if we take what we've learned in the first lesson and the second lesson, let's take this guy right here and consider him for a second. What do you think this will look like? Take a second to jot down domain, range, and transformations. What do you think is going to happen? Okay, so now that you've had some time, here's what it will look like. First of all, this value C is going to shift your function down 4 units. A is not 1 anymore, it's 2. So there is a vertical stretch of your function. It's getting bigger faster. There's no reflection because A wasn't negative, but it did stretch. Let's take another one. I'm just going to type this in here as I'm recording. So let's say that I have the function y equals negative 1/3 x squared. And let's say plus 5. What the heck? Okay, so we have lots of things going on here. Okay, domain is still all reals. Your range is going to be y is less than this time because the parabola is going down. It's y is less than 5. Okay, there transformations, there's quite a few transformations. If you just start at the front and work your way to the back, this negative sign gives us an x reflection. The next thing is this 1/3. 1/3 gives us a vertical shrink. And the last thing here in this function is plus 5. That moves it up 5. So when we typically would do something like this in class, you guys, there'd be a whole category of stuff for transformations. And that is really what I fixate on, because I feel like if you can describe the transformations, you should have a pretty good idea of what that picture is going to look like with respect to that blue parent graph. So the last thing before I give you guys the time to go ahead and do your assignment is I want you to take a look at this here. So we have this set up so that A is a slider, and we already talked about in the first lesson what A does. If A gets bigger than 1, it's a vertical stretch. Okay, so you can see those values bigger than 1, and the bigger I make it, the further it goes up and faster. If A is a value that is between 0 and 1, like 0.9, 0.5, that'd be a half, 0.3, and anything in there, it is a vertical shrink. Okay, A cannot be 0. It doesn't make it a quadratic function anymore. But if I make it negative, you can see that it reflects across that x-axis. And you can see there with negative 0.1, it's still a shrink. Okay, here's just a reflection in the x-axis. If it's just negative 1, there's no stretch or shrink. It's just an x reflection. And then anything bigger than negative 1 going negative obviously is a stretch. Okay, there's all of the moves with A. Now, if A is back to 1, let's get that slider put there. If A is back to 1 and I slide C, you can see here that the shape did not change. All it's doing is taking your axis of symmetry, or excuse, yeah, your vertex, not your axis of symmetry, that hasn't moved yet. It's taking your vertex and it's moving it up or down. That's all the value of C does. Now, when we throw B in the mix on the next lesson, it's going to change things up, and we're going to have to really fixate on the axis of symmetry and what it does to our function. But as far as this lesson goes, you guys, that's all I have for you. Again, make sure you're going through those Google Forms and understanding what's going on. Ask questions if you have them. Good luck. Thanks, guys.